So, good morning again. I am very happy to be part of this colloquium. My name is Widat, and I am a PhD candidate at Centrale Supélec. I'm also based in Centrale Casablanca in the Complex System and Interactions Laboratory. And my presentation of today is titled the Casablanca Multimodal Balanced Floating Catchment Area for measuring spatial accessibility to healthcare facilities. In this presentation, I will try to answer questions such as how is it easy for people in Al Bayda area to access primary health care facilities? And Al Bayda area is Casablanca city and its surrounding districts. The second question is how does people's adoption of different transportation modes affect spatial accessibility to public hospitals? Before going further, I would like to give you a few points regarding spatial accessibility. Accessibility in general is a measurement that helps us to know how easy is it for people to enter any kind of urban facilities and or any kind of opportunities. For example, schools, healthcare facilities, hospitals, workplaces, etc. And the spatial accessibility is based on four main components. The transport components, in which we take into account the effort of one to travel from point A to point B. The individual components, in which we take into considerations the socioeconomic segregations of people and the needs of any one of people who are living in a study area. The land use components, which tackles spatial distributions of opportunities within our study area again. And finally, the temporal components that considers the available time for each one of the opportunities. So in the literature, it was recommended to take into consideration most of the four main components of accessibility. Then again, in the literature, we found four main approaches to compute accessibility. The utility-based approach or family of measures, which sees accessibility or spatial accessibility as the economic gain that people have after accessing any kind of opportunities. The person-based measures which takes into account the opportunities people can get access with predetermined time, and people who were interested in this family of measures or in this approach used what we call the time prisms, the spatial time prisms, in which they were able to see what kind of opportunities people have access to within a predetermined time. The infrastructure-based measures assess accessibility from a point of view of travel time, congestion, average travel speed, etc. Meaning they measure spatial accessibility from performance metrics like distance or travel time, for example. And finally, the location-based measures that compute accessibility within spatially distributed opportunities. And one of the more developed family of measures based on the location-based approach is what we call the floating catchment area family of metrics. And the first index of this family was what we call the two-step floating catchment area. And it was called so because we can compute spatial accessibility using this metric in exactly two steps. The first step is to calculate a ratio. For example, if we take the example of hospitals as an opportunities, and we are interested to know the spatial accessibility in places where people are living, the first step is to calculate the capacity per people who are floating in the catchment area of each one of the hospitals. For example, for this hospital, we are going to measure the number the capacity as the number of hospitals beds or the number of doctors who are working here per the number of people who are floating in the catchment area. We are going to do the same thing for the second hospitals and so on and so forth. In the second step, we are going to go to each one of the places and sum the ratios we calculated in the first step. And this one gonna be the results of spatial accessibility. For example, for people who are living here, their spatial accessibility is the ratio of this one hospital because it was the only one who has been floated in their catchment area. For people who are living in the second place, their spatial accessibility is the sum of the two ratios of the two hospitals that have been floating in their catchment area. And in the third place, where people are living, their accessibility is none because no hospital has been floating in their catchment area. However, the first metrics have a lot of limitations, especially the failure to consider differences within the same catchment area, meaning that people who are living in all the area from a point of view of this metrics have the same accessibility, which is not the case. And so we had some more indexes in the same families, which try to overcome many drawbacks of the first metric. For example, the enhanced two-step floating catchment area, which divides the catchment area into many zones and gives different decay function for each one of these zones. The kernel two-step density, two-step floating catchment area is exactly the same thing as the enhanced, except that it's used continuous distance decay functions and many more indexes which try, as I said, to overcome difficulties and the drawbacks of the first ones. But however, the most developed metrics of all the floating catchment area metrics is what we call the balanced floating catchment area. However, this metrics does not consider more than one transport mode. And the second drawback that we found is that the catchment size amongst all population and facilities were uniform. And therefore, we suggest to have a new matrix that we call the Casablanca multimodal balanced floating catchment area, in which we were able to use more than one modes within this matrix and to have different catchment size to do our calculations. We applied the metrics that we developed into the context of North African metropolises of Casablanca city and its surrounding districts. And Casablanca is the most populated area in Morocco with about 4.2 million inhabitants. And in the last decades, this area has experienced growths and expansions of its geographical extent, making it a very interesting study case for our accessibility computation. And following this growth, new transportation forms have emerged, especially the tramways and the replacement of the buses company in the study area. In Casablanca, we still have low car ownership compared to European cities, Paris, for example, but it's already growing and already making some congestion problems. Other problems that we can see in Casablanca is a pollution, for example, and some accessibility issues. Now I will give a brief description of the process we followed in order to compute the metrics I described before. The first part was the data collection, And we were interested to have the road networks, and we did so by downloading it from the OpenStreetMap. The data set regarding public hospitals was extracted from from a public data set of Moroccan health sites, and it was enriched by the informations and reports from the Moroccan Ministry of Health. Population data set density was extracted from the World Pop data set. And lastly, transit or public transportation data was extracted from OpenStreetMap and the official websites of the public transport companies in Morocco, mainly Casa Tramway and Casabus. And these informations were basically stops and lines, locations, frequencies of travels or of trips, and the travel time between two successive stop pairs. Then we had, in order to continue our process, we had to make the transit information or data in the correct form, or the standardize it in order to be able to calculate, for example, the cost matrix. So to do so, we had to create GTFS files, which are few files that describes how transit company work basically. And to do so, we took the stops information, stop location, the frequency of trips, and travel durations between the two successive stops that we were able to get in order to create files such as like stop text files, stop time files, trips, agency information, etc. Then once we got the GTFS files and the road network data that we got from the OpenStreetMap, we use an OpenTrip planner to create a graph. And once we did so, we were already able to see some or to experience some trips within the study area. But we were interested more in creating the cost matrix in terms or based on the travel time. I mean, the travel time from each one of the central points of the population and the hospital's location. To do so, we used a script, an open script that we found, and we used the graph that we created in order to get the cost matrix. And our methodology were based on different catchment size determinations, because each one of the hospitals has to have a different catchment size and therefore different catchment area, because each one of the hospitals has different capacity, different ability to attract people, depending on its type, mainly in Morocco in general and in Casablanca in particular. Same thing was done for people catchment size determination. We were able to have different catchment size for each one of these entry points for the population using this algorithm. Then we based our weight calculation on a Gaussian function because it was the most adapted to describe the distance decay in terms of travel time for our case study. And we normalized the different weights, and we had to be sure that it meets that they meet the properties described by the balanced floating catchment area, the initial one in the floating catchment area family of metrics. And doing so, we were able to calculate. The spatial accessibility at each one of the population's location using either car or transit. The K is the mode For example, if we want to calculate accessibility in centroid number 1 for people who have cars or who are using cars, that would be one car. And we will use each one of the weights we calculated and the number of people that we know in each one of the places and that are using each one of the different transportation modes. And these are the outcomes, which are basically spatial accessibility maps in our study area. And they show the spatial patterns of and the spatial distributions of accessibility, which are interpreted as the number of hospitals bed in our study area per 1,000 people. So as you can see here, we have relatively better accessibility within the city center mainly, and the difference and the car accessibility show pretty much the same patterns as the transit accessibility. But to know the and transit accessibility results. Yes.
We lost you for 30 seconds approximately. There was a problem in the network, so we didn't hear your last 3 sentences.
Okay, should I go back? Maybe here or before?
Yes.
Okay. So here I said that here are basically the results, which are spatial accessibility maps that show spatial patterns and spatial distributions per each one of the modes. And as you can see here, we have like a relatively good accessibility within the city center of Casablanca, and the car accessibility shows the same patterns as the transit. But we were interested to know exactly the difference between or the contrast between the two modes in terms of spatial accessibility. So we plot the normalized contrast between the results and we aggregate them per district to know the districts in which people who have car or who are using car are more advantageous to access public hospitals compared to those who are using public transportation, and vice versa. The last analysis that we were able to do is the map that shows correlation between the population and accessibility results. And this one is very interesting because doing so, we were able to know places in which population is high and accessibility is low, and therefore the places in which authorities need to intervene as soon as possible. For example, in these places, in these ones. So the work I presented today present the calculation of spatial accessibility to public hospitals by two modes of transportation, which are cars and public transportation in Casablanca, using a new matrix that we call the Casablanca multimodal balanced floating catchment area. And this one takes into account the capacity of each one of the hospitals and therefore the congestion around capacity among people. And our results show spatial patterns of potential access to public hospitals in Al Bayda area. Thank you for your attention.